Nope. I just want to check my mic
Okay, you're
because
good.
yeah, because when I'm doing the group, no one can hear me. They say like,
Oh, okay. Yeah, it's working.
yeah, okay, nice.
It's working. Um, so, Justin had a comment. He said it looks complicated. It is a bit complicated. I think there's two pieces to Node that are particularly complicated when we start working with it. Okay? The first is this notion of a callback, right? That we can start code, we can do something, and then we can do something else, and then return to the first process when it completes. So, from a syntax perspective, what makes it work is this kind of strange function. We're calling a method here, but one of the parameters we're providing is a function. So one function is a parameter to another function. That's what enables in Node this callback to happen and this code to run asynchronously in a non-blocking way. And this is different syntactically and in terms of how it performs from it's kind of different from what we're used to. So it does take a little while to get comfortable with the syntax and how the non-blocking or asynchronous code works. So if you find that kind of confusing in the beginning, that's perfectly normal. So don't stress about that. But the more we work with it, after a few weeks, it's going to start to sink in and make sense. Right? So I put these slides up that I'm just going to go over. I'm not going to go over all of them, but they're here for you as a reference on Blackboard, the lesson one slides. I'm just going to go over a couple of the other points related to the mean stack just by way of introduction. So we've already talked about the components, so I'm not going to repeat myself. So it's JavaScript all the way through the stack. Okay. We know about the MVC layer, so I won't really go into that. We've already learned that last semester. But these things are just here as a refresher. Um, so one of the cool things about having, even JavaScript in our database, so even our database, the data is actually stored as JSON objects. So this increases speed because normally in a relational database, the database, every relational database has its own format. So when we want to query and pull data out of the database, we have to convert that data. I mean, we don't manually do it, it happens automatically, but there's some processing overhead to take, let's say, a list of records in SQL Server or MySQL and convert them into code that C# or PHP can understand. That whole kind of conversion goes away with the mean stack because the data is in JavaScript, the scripting languages, it's all JavaScript. So that gives us a performance boost. And MongoDB actually uses a form of JSON called Bison. So it converts our JSON objects into ones and zeros. And that's how the data actually gets stored in our MongoDB. So something like this. So here's how the pieces of the stack kind of fit together. We've got MongoDB on the back end. We've got a client app here. Angular or React or Vue, as you mentioned, could be used as a front-end framework for building a dynamic front end. Our Node.js, this runs our server-side script. It handles the client and server requests. And then Express kind of sits in between Node and the database. It routes our request. It lets us deal with our database. Right? So Node's been around for a while, and in that little video, he mentioned the creator, who was actually an engineer at Google. His name was Ryan Dahl. There's actually a video on YouTube. I wasn't going to show it to you because it's about 50 minutes, but it's kind of worth watching, where Ryan Dahl he's doing a kind of a tutorial at Google where he's introducing Node, and he explains that he came up with this idea that JavaScript would allow him to write asynchronous code so that things wouldn't block. And that way he could make web applications that ran much faster than traditional ones. So we've talked about event-driven programming already. So one of the other components we're going to use in Node, an important component, is called NPM. Has anybody worked with NPM before or know what it is? It's like that. So NPM is the Node package manager. So Nick, you're close. So NuGet is like the Microsoft version. So NuGet was actually the Node NPM is actually older. The Node package manager came first, and then Microsoft copied the idea. So same sort of idea, right? So what did we use NuGet for? What was the purpose of it? We used it a lot last semester. Yeah, basically for extensions. So we wanted to find extra functionality in our application rather than writing the code ourselves. We could search NuGet for a package library to do something like, Google login. Yes, so Yarn is an option. There are now, so for years, Node NPM was kind of the standard package manager for Node. It has some competitors. So Yarn is one of them. There are some other ones. Gulp is another one. So they all do similar things. There's a registry of packages or modules that we can download and install. And it has a CLI command line interface for managing, downloading, installing, updating packages. So we'll work with NPM, I think, starting next week. So installing a package, kind of similar again to what we did in .NET Core. We would type npm I and the name of the package name. So we want to install the Express package, we type npm I express, and it would add that package to our project. You can skip over some of these. There's also an important file in our Node application called package.json. And package.json, it tracks all of these npm packages, all of the dependencies that our application needs. So we can see them all in one JSON file. So it might look something like this. It has a name and version of our application, and then it has a list of all of the dependencies that we're using. We'll get to that stuff next week. So when we download packages with NPM, they go into a folder called Node Modules, which stores all our dependencies. Okay, I think we can leave the rest of this. We'll get into some of this stuff more with NPM next week. Okay. So these slides are all here for you as a reference. Okay, I will take one quick look at this link as well, because we did talk about this a little bit. I won't read the whole article to you, but this article kind of gives a bit of a look at where is Node appropriate? When would a Node.js solution? Maria, yeah, that's a great question. That's kind of what this article is speaking to. How do we determine what framework would be good for a web application? Do we want to use Node, or do we want to use something like PHP or ASP.NET? Okay, so in one sentence, Node shines in real-time web apps employing push technology over WebSockets. So where the app is pushing data regularly, Node's really good at this because of its asynchronous kind of socket-based nature. It's not a silver bullet for everything. Okay, it's a platform that fulfills a particular need. Okay, so for example, we don't want to use Node for CPU intensive operations. So if we're building an application with a lot of complex logic, calculation, and server processing, Node's not a great fit for that. Okay? It shines for building fast, scalable network applications that can handle a huge number of simultaneous connections, high scalability. Okay, so I think Maggie, you mentioned something like social media earlier. Node's perfect for that. Okay, so it operates on a single thread using non-blocking calls, which supports tens of thousands of concurrent connections in its event loop. Okay, so I've linked to this article. I would suggest you have a read through it. So here, in a traditional app, whereas the node model, all the requests go into a single thread. It talks about node here. So for example, here's some good examples of using node for chat, real-time communication where we want messages to appear without pages reloading. Node is great for that. Node is great for building an API. So we have some kind of NoSQL database and we want to give access to other applications to that database. We can use Node, because it's all JSON, remember, to build an API. Let's say for a mobile app to talk to. So Node's a great choice there. We're streaming data like video or audio. Node's a good choice. Or some sort of monitoring dashboard. Actually, I'll show you one quickly. But this is a student research project some students working on. So this is a monitoring dashboard, and it runs on a Linux server. So using ASP.NET wasn't really an option for this. Our options were basically PHP or Node. So we decided to use Node. I'll kind of give you a sense of what it looks like. So this is for monitoring a manufacturing facility. And the idea is we're reporting on what's happening in the facility like every 10 seconds or every 60 seconds. We're surveying the network, checking all of the devices, and reading. This is just a demo, just dummy data. We're reading device data. So we have lots of data coming in here, but the data is fairly simple. And it runs on a Linux server. So the mean stack is a great solution for this. Lots of data, simple data model, high availability, and a Linux server. So we have a MongoDB backend, and we've used Node and Express to build the app. Okay. So this is part of, Maria, you've really asked a key question. When we sit down to build a new project, it's kind of like, if you're doing construction or renovation, you don't just have one tool in your tool belt, right? You have a whole bunch of tools. And depending on what it is you're asked to build, you've got to pick the right tool for the job. So PHP is the right answer sometimes. .NET is the right answer sometimes. Mean stack is the right answer in other situations. So it's kind of, it's all about, as you said, it all depends on the needs of the project and the infrastructure is what it boils down to. Right? So we're trying to give you experience with all of these tools. So let's go ahead and let's do a little bit of coding. Let's play around a little bit and write a few simple files. I don't think we'll need our full 3 hours today, but let's write some simple files in Node. So I'm going to open up WebStorm and I'm going to make a new project for today. For the first few weeks, I'm just going to create a project for each week. And then in week maybe 3 or 4, we'll pick an application, and then we'll build that one application out the rest of the semester. What the heck? I guess we could even do that today. That's fine. So I'm going to open up WebStorm, or you can open up Visual Studio Code, whatever you like. I'm going to make a new project, and I'll just call it, keep it simple. I'll call it W21, winter 21. Now I'm going to save it in a particular place, and I'm going to recommend you do the same. If you're on Windows, I'm going to recommend you save this inside your users directory and your username. And then I created a node folder here. I'm going to put it in here. If you're on Mac, the path to your user directory is a little different, but I would recommend inside of there. So it's like somebody who's on a Mac, what is your user path? It's like USR / your username. What's your root user directory on Mac? Okay, in WebStorm projects. I'm curious though where I want you to put it. Justin, you can put it where you want, but here's the thing. You want to put it wherever your default location is when you open your command prompt or terminal, because we're going to use the command prompt or terminal every class. So yeah, so what I recommend is you put this inside of, so I'm going to open up, go here, and go to Node.js. I'm going to open my Node.js command prompt. See, so for me, it opens at C users R Freeman. So I want to put it in here. For the moment, we're just creating an empty folder. So my recommendation is open up your command prompt or your terminal. Whatever directory it's in, I would create node W21 inside the default command prompt or terminal directory. So you don't have to, you can put it anywhere, but then you're going to have to browse to that other place in your computer every time we go to the command prompt to launch our application. So it's going to be a lot more efficient if you create it inside of whatever the, well, I didn't create any file. Justin, it's in the message right above in the chat. So I'm creating it as node W/W21. So I'm going to create a node folder for the course and then a project folder for our in-class exercises. So you might first want to create a node folder and then create the W21. Again, you can put it wherever you like, but it's going to be easiest inside your user directory. Because as soon as you open your terminal, that's where you are, or your command prompt. You can always move it later, so it's not a huge problem if you need to move it. So now in my terminal, in my command prompt, I'm going to go into this directory. So I'm going to write cd node W21. So I'm changing my directory. So now inside my command prompt, I'm in the same folder where my project is. My folder is empty right now. There's nothing here. I've just built an empty folder. So there's nothing here. When I browse in Windows, it's empty. If I try a command that says dir, right, there's nothing here. That's fine. To verify that node is installed, you can run the command node -v. And this will tell you which version. I just updated my node this morning to the latest stable. So run the command node -v. If you're not on the latest version, that's fine. You just want to make sure you get some version. If you don't get anything, then node is not installed for you, and you'll have to rerun the install. Yep, that's fine. The folder should be empty. That means you're doing it right, Justin. Don't panic. Okay, but when you run node -v, yeah, you should get some version number. It should say v. That's just, I think, because I'm on Windows, I think you're on Mac, correct? The idea folder is just a hidden folder. Don't worry about it if you don't see it. Oh, okay. That's fine. Don't worry about it. Are you using WebStorm or a different editor? That's why. This folder is a hidden folder created by WebStorm. Yeah, that's fine. So let's create our first file here. We're going to create the world's simplest node file. So I'm going to right click. I'm going to create a new JavaScript file that will give the super original name of Hello World with no spaces. So we want to print the message to the console. So we're just going to use console.log, which you've probably used before in some of your JavaScript classes. So here's our file, pretty simple. Just a simple console log message. You can have the message say whatever you want. It doesn't have to say hello world. So now I want to run my file. So I can just type the command node space and then the name of my file. I don't need the extension. So we're going to run this command, and it just spits out our little JavaScript message here. So pretty simple. So to run a JavaScript file at the command prompt, we just type node and the name of our file. Now we want to actually build Node to write, we want to use Node to build web pages. This file just kind of loads in the command prompt. It doesn't actually, it's not something we're using in the browser. So let's try a bit more advanced example next. So I'm going to make a new file, new JavaScript file. I'll call this webserver.js. So this is a page we actually want to be able to call from our browser using localhost. Okay. So Node is different from something like ASP.NET or PHP. When we had our PHP class, we had to install the Apache web server in order to run our pages locally. When we did ASP.NET, Visual Studio includes IIS Express, which is a local web server, which we use to serve the pages. Node actually comes with its own library. It also comes with a library, but we have to manually invoke it. We can't just kind of run the project like we did in Visual Studio. So we're going to use Node's built-in HTTP module to create and start a local web server. Okay, so when we install Node, Node comes with a bunch of libraries, and one of them is a library for running a web server. So we'll create a constant of HTTP, and to add in the dependency to this library, we are going to require the HTTP module. Oops. So then we can use the HTTP functions that come with Node. So we want to start the local web server. So this library has a built-in method. And again, this is why I like WebStorm. It inspects this module and it brings up all of the methods that are available to us. So we want a method called, not sure why it's not showing up, create server. So I'm kind of following the example that was in the little video, the 11-minute video we watched from Code School. So when we call create server, this is going to run asynchronously and listen for events. So the two events we're interested in is the request event, when a user requests a page from the web server, and then the response event. So we're checking for HTTP request and response events. So now we have this weird callback syntax. We're going to set up two parameters, a request and a response. So we've got one function that's a parameter to another function. So in here, what should happen when we get an HTTP request? We're going to send an HTTP header of 200. And we're also going to set our response type just in plain text for now. And then we want to write some text to the HTTP response. So we're going to write a response that says hello world, and then we'll end the response. So anytime a request event happens, we're going to send a response with a 200 HTTP status code. We're going to send some text back, and we're going to end the response. The last thing we need to do when we're creating our server is we need to tell the server to listen for events. And we have to provide a port. So this is going to run on port 3000. So I'm going to save this. I'll put all the code up on paste bin, and then we can try this page out. No, it can be any port. Good question, Justin. But by default, when we use Express, Express runs on port 3000. So I'm going to use port 3000 for consistency. because later when we use Express, it will automatically run everything on port 3000. So I'll put the link in the chat so you can check the code. So now how do I run this? Right? Our page is going to create a server, listen for requests, and every time a request event happens, it's going to create a new HTTP response with an OK status and a message that says hello world. And this is going to listen constantly for new events on port 3000. So if I go here right now and try it out, I can go to localhost 3000/web server. But I get this, can't establish a connection. So what we have to do to fix this is we have to actually call this file from the command line to start our server. Our server's not active yet. So how from the command line, if you think about how we ran our last file, what command should we write in the command line to start our server running? So we've created the file, but now we want to launch it to get our server to execute and listen for HTTP requests. Yep, Rebecca, you got it. Maggie, we're part right, but we need the node command in front of it. So we're going to use node to launch our web server. And you'll notice now my command prompt is locked. I can't actually type. So if I refresh, now our server is running, right? So I could use different browsers and our server is active. So it's going to be listening. Every time it gets an HTTP request, it now sends this response. And if we check in the network tab, if I refresh, here's our 200 response that we are sending, along with our content. So our code's working. I'm going to add one more line to this file. Right? My command prompt is now locked. If I try typing anything in the command prompt, I can't because my server's active, right? This listen, this is a continuous process. It keeps listening for events. So I'm going to add one more thing here. I want to add a message after we start the server. We want to display a message in the console. So I'll use console.log and maybe just say server running at HTTP localhost 3000. So we'll add this to the bottom so when our server starts up, we'll get kind of a confirmation here in the console. Because right now, all we get is kind of a blinking locked cursor. We know it works in the browser, but there's no indication here that when we started this up, that it worked. So how do I unlock it? Anybody have an idea? If I try typing, nothing happens because my server's active and my command prompt is kind of locked here. Thank you, Ivan. Yeah, we could close the whole tab, but that actually won't, the server will actually still be running. If we do Control-C, it now stops the server. It brings me back to a flashing command prompt. So I now want to relaunch my server. So there's two ways I could do it. I could type as Rebecca suggested, I could type node web server again. That would work. I can also hit the up arrow on my keyboard. If you use the up and down arrows on your keyboard in the terminal or command prompt, it actually cycles through all the previous commands. So if I just hit the up arrow once, it will repeat the command I ran previously. So I'll hit enter again. This time, before it locks my cursor, it says server running at localhost 3000. And my server's working. No, Justin, you can't. That's a good question, Ivan. I think because it isn't actually an actual page I'm loading, I'm just sending a text response. I think, but I'm not 100% sure. So we're going to try one more thing with this file. Right, so my server's active and running. I'm going to change this message. We'll say, hello world. Okay, Rudia, does it say your server's running in the command prompt? And is your cursor just blinking here? Yes, you can use the terminal in Visual Studio if you like, yes. I like having it in a different window because I can move it around, so it's easier for you guys to see. In WebStorm or Visual Studio, so there is a terminal right here. So if you want, you can use this. That's fine too. And Visual Studio Code has a similar terminal. So I'm just going to make a change to the response. I'll say, hello world, our first node page. I'm going to save that change. And then I'm going to go back to the browser, right? So I've changed line 10, and I'm going to hit refresh. Notice what happens. Right, so Rudy, I'll come back to you in a minute. So notice my update, my site hasn't been updated. Barak is right. It's giving me the old response. Why do you suppose this is? Why didn't it update? You got it, Barak. So once we launch the server, the changes don't happen automatically. So I've got to hit Control C, hit my up arrow to restart the server. And now it's giving me the new response. So this can be a bit of a pain with Node, that when we make changes and save them, things don't automatically refresh with Node until the server is restarted, as Barak said. Okay. Now, there are some tools we can add on that will do an automatic restart. It'll watch for changes, and anytime we save new files, the server will automatically do a restart. So we'll look at using those tools, maybe one of those tools next week when we work with NPM, because we'll want to add an NPM package into our project that will watch for changes and do an automatic restart. Okay, Rudia, so yours is blinking. Is it blinking right on the left, or is it blinking at the end? Does it show your file path and then the cursor? Same as mine. Okay, and what happens? What message do you get when you try it in the browser? Okay, so is there an error message? browser won't open automatically. You have to actually go to a tab and enter this address. Yeah, it doesn't open automatically. You have to go and do it. Yes, the code will always be on GitHub at the end of class. Absolutely. Okay, so there's our first simple page. I'm going to hit Control-C and stop it again, because we want to try a couple of other files. Okay, so we're going to do build two other files today. Okay, that's fine. I will record the last part of class and the code will be on GitHub for you to review and try out later on. Hope you feel better, Nadine. We'll see you next week. There's no homework or quiz this week, okay? We're going to kind of ease into things. Link is already on, good, Rudia. Link is already on Blackboard. Under Weekly Learning, Tools and Resources, there's the link to the video playlist and the link to my GitHub page. No, it doesn't open automatically, Rudia. Okay, so what we're going to do, it's actually almost time for us to take a break, but what we'll do, I'm just going to point out, we're kind of going to do our own version of a sample from his video. So what we're going to do is we're going to build two text files of different lengths, and then we're going to try reading them. We're going to write one file, we're going to write a blocking file that tries to read one file and then read the other file, and we can see the output. And then we're going to try reading the two files at the same time in non-blocking code. So we can see the differences both in how we write the blocking and non-blocking code, and also we can see the differences in how they perform, reading the exact same files, okay? So I don't think, we should be done a little bit early today. I don't think this will take us like all the way till 3 o'clock or 2:50 to do. But it's 1:49 on my clock. So let's take a break here. We'll come back at 2 o'clock and then we'll try our own version of blocking versus non-blocking. So we can kind of play around and experiment with how that works. Okay, let's take a break here.